Okay, so our learning goals are learning the new terminology appropriate for right triangle trigonometry. So there's going to be new terms that you probably haven't heard before, okay? And then learning that trigonometry is the relationship between the ratios of the lengths of the sides in right triangles, okay? It's really a set of 3 formulas for today that we're going to learn. And then we're going to learn how to know what to use which formula when. And they're really easy formulas to use, okay? So a right angled triangle has one angle that is 90 degrees. And because there's 180 degrees in a triangle, if one of these 90, that means the other two have to be smaller than 90. Does everyone agree with that? Because 90 and 90 is 180. So the other two have to be smaller than 90. In other words, both of these angles are acute angles smaller than 90. Does that make sense? The longest side of the right angle triangle is across from the right angle. It's called the hypotenuse. The legs, so last year in grade 9, the other sides that aren't the hypotenuse were called the legs of the right triangle, are named in trigonometry, okay, according to the acute angle that you're naming them from, okay? So that it changes depending on which angle you're naming them from. So the side opposite, that should say from, the acute angle is called the opposite. So here's my acute angle I'm naming from. This symbol here is a Greek letter, and that Greek letter is theta, Theta. Okay? And instead of using x as an angle, as we use it as an unknown side mostly, they go to the Greek alphabet for unknown angles. So theta is an angle that we don't know the size of. Okay? All right, so it's easy to name the sides of a right triangle. Find the right angle, and the side across from it is the hypotenuse like it was last year. Across from the angle you're naming from is the opposite side. It's opposite to the angle you're naming from. Okay? And then the other side that helps form the angle with the hypotenuse, so the hypotenuse and the adjacent side always form the angle. Adjacent means joins with, connects to, okay, joins with, so it joins with the hypotenuse to make the angle, okay? So there's 3 sides that you have to be able to name. So name the side of each triangle, hypotenuse, opposite, and adjacent, and we can just use the first 3 letters. So we can name the sides height, up, and adj, so we don't have to write out the entire word each time, according to the acute angle indicated. So theta is the acute angle we're naming from. So if you can name the 3 sides, then you'll be able to pick the right formula, and then it will all work for you today, okay? So there's my right angle. So my thinking is I know that's the hypotenuse. Okay? Here's the angle I'm naming from. So I think to myself, the side across from it is the opposite. And the other side is the adjacent. Okay? So here's the right angle. The side across from the right angle is always the longest side, the hypotenuse. Here's the angle I'm naming from, theta. The side directly across from that angle is called the opposite side. And the other side that helps form the angle is the adjacent. Okay? So try the next 2, C and D, and see if you can name the sides properly. Okay, so if I was doing C, here's my right angle, so this is my hypotenuse. The angle I'm naming from is theta, so the side across from it is the opposite side. And then the side that helps form the angle, or the leftover side, in other words, is the adjacent side. How many people named the side properly? Okay, naming the sides is the important thing here. So hypotenuse, opposite, the angle, adjacent. Okay? All right, good. So we're going to kind of see how trigonometry works in this exercise. So I'm going to work together with you. I've got a ruler. You guys have a ruler. Measure and complete the following table for the following right angle, 30-degree similar triangles. Similar triangles have exactly the same shape. Can you see that this little triangle and the medium one and the big one all have exactly the same shape? Okay. And how do we know they have the same shape? They all have a 90-degree and a 30-degree angle, which means they all have a 60-degree up at the top. Is everybody good? So if the three angles are the same, then they're the same shape. You can definitely see that this is the smallest one, this is the medium one, and this is the large one. Everyone see that? Okay. All right, so triangle, small triangle, what's the length of the opposite? So we're going to measure the opposite, adjacent, and the hypotenuse for the small triangle, the first one. Okay, to the nearest millimeter, I'm going to put my glasses on, and then we'll just kind of get a consensus from the class and figure it out. So we're measuring the opposite first, which is the vertical one, according to the 30 degrees. To the nearest millimeter. .2. So let's go to the outside for everyone.
I have like one. You just go up a bit more than.
Yeah, so you're measuring from like here to here. We're consistent, then we'll measure from here to here, and then we'll measure from here to here. Okay, does that make sense? So what I'm interested in is what you're getting for this one. We've got two of us got 2.2. Did anyone get something different? 2.3. 2.3. How many people got 2.3? Okay, we're gonna go with 2.3. Okay, so now we're measuring the adjacent, so that's from here, the tip, to here. So I've got 3.7. How many people? 3.7. A little different. 3.7. That was the adjacent. 3.7. And then length of the hypotenuse, we're doing that. So from the tip to the top. 4.2. 4.3. 4.3. Okay, so now we're going to do the medium triangle. So the opposite side is this side from here to here. And the adjacent is going to be from here to here. And the hypotenuse from here to here. Okay, for the medium triangle. We're doing the opposite first. 3.9. And the adjacent. call it 6.1 or 6.15. 6.2. 6.1 is it? So, okay, let's do 6.15. That's where it looks like on mine, and some people are getting 1 and some people are getting 2. And then hypotenuse, the medium one. Hmm. 7.2. Yeah. Okay, now we're going to do the big triangle. So the opposite is from here to here. The adjacent is from here to here. And the hypotenuse is from here up to here. Seven exactly is the opposite.
I got one.
You have 11? 11, okay, so it's 11. And hypotenuse? Let's see how good we are. There.
I got 12.9.
I got 13. Anyone? 13? Okay. The calculator will tell us how close we did. All right, so now that we've done all the measuring, we don't need our ruler anymore. Now it wants us to divide, for the small triangle, the opposite divided by the hypotenuse to 1 decimal place. So the 2.3 divided by 4.3. 0.5 to 1 decimal place. Okay. And then adjacent, 3.7 divided by 4.3. 0.9 to 1 decimal place. And then opposite divided by adjacent, so that's this one divided by this one. 2.3 divided by 3.7, 0.6. Same thing for the green ones. So opposite divided by hypotenuse first. 0.5. They should be, yes. Very good. Adjacent divided by hypotenuse is 6.15 divided by 7.2, 0.9 again. And then adjacent divided by adjacent, my bad. 3.9 divided by 6.15, 0.6. Okay, red. So opposite divided by hypotenuse, 7 divided by 13, 0.5. Adjacent divided by hypotenuse, 0.8. And opposite divided by adjacent, 6. And then the bottom column is the average, so if all three are 0.5, then the average is 0.5. Our average is 0.9 to 1 decimal place here, and our average is 0.6 instead of 0.6. Okay. So now we're going to use our calculator, and we're going to type in the sine of 30 degrees So some calculators you press sine and then 30 and then equals, and other calculators you press 30 and then sine and then equals. So figure out which one yours is. Okay? So sine 30, you should get 0.5 on your calculator. Okay, exactly. You press sine and then 30, you get 0.5. Right here, 0.5. Okay, so your calculator could be in another mode. So if you didn't get 0.5, put your hand up and I'll come and put your calculator in back on. Yeah, your radians. So there should be a button that switch right there. So you can press that button. It says radians, it says degrees. Okay. Who else? Okay, so go to mode. Yes, your radians. Degrees and years and down. Yep. Okay. Yeah, so your gradients. So you grab that your V, then gradients. That's gradients on a metaphor. Okay. Anyone else can get your calculator? Yeah. Oh, yeah. That's your thanks. Okay, that's your All right, so what did we get for cos of 30? Okay, we're gonna keep 4 decimal places. So 0.8660. Okay? And it goes on, but keep 4 for trig if you have to. Mostly we're just gonna let our calculator do the work for us. Okay? And then the tan of 30 is 0.5774, I guess, if you round to 4 decimal places. So here's our 0.5 column. So this is our sine column. And sine is opposite over hypotenuse. Okay? This is our cosine column. And cosine is the length of the adjacent divided by the hypotenuse. And this is our tan column. And tan is the length of the opposite divided by the length of the adjacent. Okay? If you know it's 90 degrees, one angle and one side, you can find every other measurement, which is cool. Okay? All right, so the sine, cosine, and tangent ratios are the formulas for right angle triangle trigonometry. Okay? So here they are. So the sine of an acute angle that we'll use as theta is equal to the length of the opposite side. So we use OPP for that, length of the opposite side over the length of the hypotenuse. The cosine of angle theta is equal to the length of the adjacent side, so ABJ, over the length of the hypotenuse. And the tangent of angle theta is equal to the length of the opposite divided by the length of the adjacent. So those are your 3 formulas for trigonometry, but also keep in mind that there's 2 things from grade 9 you should also know about right angle triangles. And that's 3 angles add up to 180. Okay, that's true. Everybody agree with that? And then, does Pythagorean theorem apply to right angle triangles? But instead of writing c squared equals a squared plus b squared, we're going to write height squared, because that's the hypotenuse, is equal to the opposite squared plus the adjacent squared. So these 2 things also apply. Those are our 3 new things for grade 10, which are super important, and they're really huge tools to finding missing sides and angles in right triangles. Everybody good? Okay, so let's try a question. Use right angle trigonometry to solve for the indicated side of each right angle triangle. So this is, we're starting trigonometry. Okay, excited. This is cool. Okay. So see how they give us this 30-degree angle? So that's the angle we're going to name our sides by. So the acute angle that you're given is what you name the sides by. So name the 3 sides: hypotenuse, opposite, and adjacent according to that 30 degrees. Okay? So that would make x the opposite. Is everybody good that x is the opposite? And the 10 centimeters is the adjacent. And then the one across from the right angle is the hypotenuse. So does everyone agree that we want to find x? That's what they're asking us to find. And we know the adjacent is 10 centimeters. But they're not asking us to find the hypotenuse, and we don't know what it is. Everyone agree with that? So that's the side we're going to cross off. So if we cross that side off, there should be one of our 3 formulas that just has opposite and adjacent in it. So if you look back on the page, which formula just has opposite and adjacent? Tan. So that's the formula we're going to write down. So we're going to write down the formula tan theta equals opposite over adjacent. So that's just the formula. Now the next step, we're going to substitute it. So based on our triangle up there, theta is the angle we named it from. So theta is 30 degrees. The opposite is x. Does everyone see that? That's what we're trying to find. And that's being divided by the adjacent, which is 10. Now remember, this is just a number that is stored in our calculator. Anytime we wanted it, we could type in tan 30. Everyone agree? Yep. So I'm gonna let my calculator do the work. But if I want to get x by itself, this is like a grade 9 equation. X divided by 10 equals something. How do I get x by itself? Times by 10 on both sides. So if you type in 10 times tan 30, that should give you what x is. So type in your calculator. So some people are going to go 10 times tan 30 equals, and some calculators go 10 times 30 tan equals. It depends on your calculator. But if you do it right, you should get your calculator to tell you to 1 decimal place 5.8, 5.77, you would round to 5.8. So 5, approximately with the dot, 5.8 centimeters. Okay? So that means if this is a 90-degree triangle, that's 30 degrees. If this is 10 centimeters, then this side's going to be 5.8 centimeters every time. Okay? Anyone not able to get that on your calculator? 5.8 or 5.77. You got it? Okay. Okay, let's go to the next one. So here's the angle that we're naming the sides by, 40 degrees. So name the three sides by the 40-degree angle. Okay, so I saw lots of people putting height on this side. And right across from the 40 degrees is your opposite. And this is your adjacent. So then you kind of ask yourself, which side am I going to cross off? Okay, the side I cross off is the side I don't know anything about and they don't ask me to find. So I know this one, so it's in. I'm asked to find this one, so it's in. This one I know nothing about, it's out. Okay? We're going to see how you made that decision, which one to cross off. So now I look back at my formulas and figure out which formula has hypotenuse and opposite in it. Sine. And then I write the formula down exactly how it is. Sine of theta equals opposite over hypotenuse. So that's write down my formula, then I substitute in. So sine of 40 degrees is equal to opposite, which is x, over hypotenuse, which is 8. So now I've got this grade 9 equation where it's x divided by 8 equals the sine of 40. Okay? So in order to undo divide by 8, I multiply by 8 on both sides. So those divide to 1. So I end up getting x is equal to approximately, and then I'm going to do 8 times the sine of 40. And to one decimal place. So sides are always going to round to one decimal place unless it says otherwise. It would be 5.1. And then look and see if there's any units. Sometimes there is, sometimes there's not. If there is, please put units. So x is approximately 5.1 centimeters. Okay. Our next one. So we name our sides according to the acute angle we're given. 50 degrees this time, we're going to name our sides. So across from the 90 is our hypotenuse. Across from the 50 is the opposite side. And the side remaining is the adjacent. So which side should I cross off? Height? Okay, I don't know it, and they're not asking me to find it. So I cross off height, and then I have to look and see what formula has opposite and adjacent in it. Tan. So the tangent of angle theta is opposite over adjacent. That's the formula. Okay? Then I substitute. Tan of angle, so 50 degrees, equals 2.6 over A. Okay, so let's put a star on this question. What's different about this question? Yeah. Yeah, the number's on top and the A that we want to find is in the bottom. Okay? So we're going to use solving equations to get A by itself. So the first step, to get A on top, I want to multiply both sides by A, because if I do that, these A's cancel out, but I've got A on the top on this side. Does that make sense? So I undo divide by A by multiplying by A, but whatever I do to one side, I do to the other. Okay? So now on the left side, I've got A times the tan of 50. And on the right side, now I just have 2.6. So these ones take an extra step when the variable's in the bottom. So now to get A by itself, I have to divide both sides by the tan of 50. So I get A by itself on this side, but whatever I do to the left side, I also have to do to the right side. So those cancel, and I'm left with A. But now I have to figure out on my calculator how to divide by that. So 2.6 divided by the tan of 50 degrees to one decimal place. 2.2, good, I got 2.18, so approximately 2.2 kilometers this time. Okay, so that's how you do it when the variable's in the bottom. Okay, algebra's a little bit trickier. Okay, so try D on your own, name the sides, cross off the one we're not using, write the formula down and see if you can get all the way to the end. I'll pause this for Lily. So hopefully you said this was the opposite side, this was our hypotenuse and our adjacent, and you crossed off the opposite. Yes? And then you looked up your formulas and you saw that cos was the formula that had adjacent and hypotenuse. And then you substituted. So the cosine of 20 degrees is equal to 12 over A. Then because the variable was in the denominator, you had to multiply both sides by the variable, which is A again. And then you have to divide both sides by the cosine of 20. And you get A equal to 12.8, approximately 12.8 centimeters. Okay? All right, try the next two. I'll pause it. Cross off the adjacent. And then opposite and hypotenuse is sine. So sine of 35 degrees is 11 over P. So a little bit trickier one, where you have to multiply both sides by P first. And divide by the sine of 35 degrees. .2 centimeters. Any questions? Yeah, any questions for you? Okay, good. Okay. F. Opposite. Hypotenuse. Adjacent. Cross off opposite. So it's cos. So my angle is 25 degrees. Adjacent is shown by a Z this time, over 9. So this is an easier kind because the variable's on top. So we can just multiply both sides by 9. And then we get Z is approximately 9 times the cosine of 25 degrees, 8.2 centimeters. Remember to use the dot, approximately dot above your equal sign, and check to see if there's units in your question. Okay, try the next two. Hopefully everyone's starting to feel pretty confident that they can figure out what side to cross off, they can name the sides, they can figure out what formula to use, and that doesn't matter whether the variable's on the top or the bottom, they can find it. Okay. Six point eight. 6.8 meters. And then opposite hypotenuse adjacent cross off opposite. So cos again. Cosine of 62 degrees is 6 over h. Variables in the denominator, so multiply both sides by h. H times the cos of 62 degrees equals 6. Divide by the cosine of 62 degrees. And we get that H is approximately 12.8. 12.8 centimeters. Okay, so that's the main idea for finding sides. Okay, be able to name the sides, pick the formula, and then solve for the variable, whether it's in the numerator or the denominator. Okay, find NP to 1 decimal place. NP, does everyone agree it's this side? Okay, so when you're using triangles, angles are always named using capital letters, and sides are always named using small letters, okay? In a certain way. So if this is angle M, the side across from angle M is little m, like lowercase m, okay? And if this is angle N, the 60 degrees, then the side opposite of that is lowercase n. And if this is angle P, the side opposite angle P, so down here, is a lowercase p. Okay, so that's how you name sides in trigonometry. So the angles are always capital letters, and the sides are always the little lowercase letter opposite the side. Okay? So they really want us to find little m is what they want us to find. And we're going to label our sides opposite, hypotenuse, and adjacent according to the 60 degrees, because that's the acute angle they give us. So according to the 60 degree, this n is the opposite side. Hypotenuse is what they want us to find. We know the opposite. We want to find the hypotenuse, so we cross off adjacent. Okay. And then, so we use the sine formula. So opposite is little n. No, it's 6, my bad. I'm writing out the formula still, getting ahead of myself. Opposite over hypotenuse. So the sine of 60 degrees is 6 over little n. So it's in the denominator, which means I have to multiply both sides by m to get it into the numerator. So I get m sine 60 equals 6. Then I have to undo multiply by sine 60 by dividing by sine 60. Divided by sine 60. So to 1 decimal place, 6.9. 6.9, and there's no units, so just leave it, 6.9.
Would you change that to NP? Or
You could. In trigonometry, these things mean exactly the same thing. That's kind of like a universal convention, so they mean each other, but it's totally good to do that as well. All right, determine the measure of RT to 1 decimal place. So again, if we use our trigonometry naming system, the side across from angle A is lowercase a, lowercase r, and I make a lowercase t by curling the bottom. You don't have to, it just looks like a plus sign though sometimes. And then you want to name your sides hypotenuse, opposite, and adjacent according to the 24 degree angle. So here's my angle. So this is my opposite side. There's my hypotenuse. And here's my adjacent. RT is this side, so they want little a. So they want that side. Then I have this side, so I'm going to cross off hypotenuse. Okay. So then I look at my formulas, see which one has opposite and adjacent in it, and it's tan. So the tangent of 24 degrees is opposite, which is little a, over adjacent, which is 33. That's an easy one because a is on the top. So just multiply both sides by 33. And we get a is approximately 14.7. And again, there was no units, so don't put units. And you could also do what Peyton suggested and also write, therefore RT is approximately 14.7. Okay, our last question is good because it asks for the perimeter of the triangle. And to know the perimeter, I would need to know all three sides. Okay? And it doesn't give me like an X on one of the sides. But in fact, I need to find both of them, right? There's a couple ways I can do that. Anyone have an idea? Yep.
So when you do 2,
Yeah, you could do 2. So you could decide, okay, first I'm going to find this side, right? Call it X. So there's my hypotenuse. According to the 45 degrees, that's my opposite. And this is my adjacent. I'd cross off the hypotenuse because I'm trying to find the opposite right now. Which means I would use tan. So tan 44 degrees is equal to the opposite, which is X, over 29. That's the easy kind where X is on top. So 29 times tan of 44. 28.0. Okay, so I'm going to leave the blue on, okay? And we found X now. And I'm going to call the side, the hypotenuse Y. I'm not going to use X again because I've already used X in this question. So I'm just going to call it this side Y. So this time I want to cross this side off because I know the 29 and I want to find the Y. So hypotenuse is back in it again, which means which formula am I going to use? Cos, because I crossed off opposite, so I've got adjacent and hypotenuse. So cos theta equals adjacent over hypotenuse. So cos 44 degrees equals adjacent is 29 over hypotenuse, which we call the y. So this is a little bit harder one where the variable's on the bottom. So when the variable's on the bottom, you have to multiply both sides by the variable to get it on the top of the other side. And you're still trying to get y by itself, so then you're going to divide by cos 44 on both sides. And we get that y is approximately 40.3. So the perimeter is exactly 29 plus x plus y. Is that a true statement? Perimeter is exactly 29 plus x plus y. But it's approximately, because x and y are rounded numbers, I can just use my calculator, 29 plus 28 plus 40.3. So perimeter is approximately 97.3. And if it's a perimeter question, I would probably write units, since there isn't any like centimeters or anything. Okay. So it's exactly 29 plus x plus y, but because x and y are rounded, it's approximately 97.3 units. Make sense? A little bit?